In last lecture discussion was on the fiber structure, morphology and effect of this on dyeing behavior on cotton, wool and silk. The polymeric behavior of fiber and fiber internal bonding, how plays a role in dyeing was discussed. Also essential quality of fabric requirements for dyeing was learned. In this lecture, the discussion will be on object of pretreatments and effect of pretreatments on dye. Cellulosic fibers, whether they are natural, that is cotton, linen, jute, remi, sisal, etc., or regenerated, that is viscose and polynogics, need some form of treatments to make them suitable for dyeing or finishing. This treatment, which removes natural and added impurities, is called preparation or pretreatment. It can be carried out on loose fibers, yarns and fabrics. Unless the fiber is uniform in whiteness, absorbency and chemical composition, that is the cellulose is not chemically modified and has low levels of impurities, waxes, lignins and electrolytes, it is unlikely that it will take up dye or finish in a uniform way or to the maximum extent possible. The prepared fabric must have fitness for purpose. For example, a fabric to be given a water repellent finish must be free from residual surfactant. Fibers used for medical end use must have low ash content, like this. The successful preparation depends on four factors. First one, the level and type of impurities present. Then the chemicals used in the various stages of preparation. Then the quality of water used for the processing. And fourth one, the type of machinery used for the processing. This type of machinery is mainly depends on the type of form of textile which decides the type of machinery. The quality of dyeing of any textile material is directly dependent on the quality of textile fibers used to manufacture the product. Moreover, to maximize dyeing process efficiency and color performance properties, the textile fibers involved must be as clean as possible. The central goal of preparation is the removal of both naturally occurring impurities and those which are added during yarn or fabric manufacturing. The dyeing process can be performed on textile fibers, yarns, fabrics or garments depending on the properties or for cost control. Preparation can also be performed at any processing stage depending on the dyeing technique employed. However, fabric preparation is typically most often used. Additionally, some commonly used optional preparation processes such as singeing or mercerization can only be performed on yarns or fabrics. Complete fiber cleanliness is not easily achieved. The degree of cleanliness of textile material is only determined by employing standard accepted testing methods and properly interpreting the data obtained. However, not all shades require the same degree of cleanliness to achieve high quality color performance. Deep, dark shades of green, brown, blue and black do not require the ultimate fiber cleanliness needed by whitest fabrics or light pastel color fabrics and bright medium colors. Regardless, the often quoted sentence is, when fabric is well prepared is half dyed. Most natural fibers are not pure cellulose but contain significant amount of other materials. The analysis of various cotton samples is summarized in table. To these natural impurities are added 10 to 15% of size, spin, finish or knitted lubricants. The spin finishes and knitting lubricants contain surfactants and mineral oils applied alone or in admixture to decrease friction on machine parts. Sizes are film forming materials used to coat the warp yarns of woven fabrics in order to minimize yarn breakages during fabric production. Starch, usually esterified or etherified, is the most common size, but polyacrylates, cellulose ethers, that is carboxymethyl cellulose, then polyvinyl alcohols and polyvinyl acetates are also used. The source from which the starch is obtained, that is from corn or rice, can affect its ease of removal. Size plasticizers such as tallow or paraffin wax are either added to the sizing liquor or applied after the size has been dried onto the yarn by kiss roll coating. Metallic ion contamination, particularly iron and copper, is of most concern during oxidative treatment, as this can be lead to chemical damage. This damage can be manifest itself as a very localized destruction of the fiber or reduced diaptic. This form of contamination can result from the growing area where the plant absorbs the mineral matter through its roots, or the wind simply blows the soil onto the fiber. It can also arise from washing off with contaminated water or heating with contaminated steam. The second factor is chemicals used in the pretreatment. Many types of chemicals are used in preparation. These include enzymes, that is alpha amylase or cellulase, then alkalis, in that caustic soda, soda ash and phosphates, then bleach bath stabilizers, that is silicate and organic stabilizers, then sequestrants, that is amino and hydroxy polycarboxylic acids or aminomethyl phosphonates or sodium polyphosphonates, then oxidative bleaching agents, that is hydrogen peroxide and sodium chloride and hypochlorite, and reducing agents, that is sodium bisulfite and hydrosulfite. To these main components are added the auxiliaries and usually surfactants to assist in wetting, scouring and detergency. While selecting these chemicals, one should see that optimum concentration and proper combination of chemicals to be used, because excess concentration of chemicals will demand more consumption of water and traces of chemicals will be remain over fiber, which will create a problem during dyeing. In the pretreatment, the third important factor is the purity of processing water has a direct effect on the performance of the preparation process, which cleans the fiber and the efficiency of the dyeing process and the end product color properties. Poor quality processing water creates all type of problems during the preparation and dyeing processes, including color defects in the end product. Regardless of the source, the processed water should be routinely analyzed. Key issues include water hardness, alkalinity or acidity, also known as pH of water, then turbidity, that is suspended solids, then sediments, then dissolved organic matters, then dissolved minerals such as iron, copper and zinc chlorine content, and color of the processed water. Most textile processing units using river water which provided a copious supply of good quality water, that is water with low suspended solids, neutral reaction and low metallic ion content. Particularly transition of heavy metal ions. The need for the following quality factor is self-evident. Any suspended solid are likely to be filtered out onto fiber, yarn or fabric. Then high or low pH could cause spontaneous uncontrolled reactions to occur. Metallic ions may give rise to discoloration, stains or chemical damage, that is catalytic tendering of the substrate during bleaching. To get consistent good quality of water, some following precautions are to be taken. Sand filters to remove suspended solids so fiber surface can remain absorbent. Neutralize to give a pH around 7 for controlled reaction during pretreatment and dyeing. Treat if required to remove residual chlorine becomes essential when rushing of water to minimize water consumption. Soften to remove calcium and magnesium ions for avoiding insoluble deposition of complex on the fiber, due to which absorbency and feel of the fabric affects. And the last one, treat to precipitate heavy metals ions to avoid degradation of fabric during chemical treatment, also to control final ash content of the fabric. The fourth important factor in the pretreatment is the machine type used for the pretreatment. The machinery used for preparation is to a large extent controlled by the physical form of textile being processed. Textile processing is performed in different forms like loose stock, yarns or fabrics. Machine used depends on form of textile. Also, consumption of chemicals and water depends on type of machine. For fiber processing, batch size is important because depends on batch size, machine for fiber processing is selected. For yarn processing, hank or package form decides the machine. In case of knitted goods, whether in tubular or slit form of knit is considered before selecting the machine. For woven fabric, processing is done either in a rope form or open width form, depends on quality of the fabric which decides the machine. Also, it is taken in consideration that which type of process is to be adopted. Batch process, that is performing on kears, jiggers, winch, package dyeing machine, hang dyeing machine, etc. Semi-continuous type of processes where pad roll, pad batch, etc. Or continuous processes, that is J-box and continuous bleaching rate, etc. This decision is mainly depends on production capacity and quality of the fabric. After discussion of 4 dependent factors, those are level and type of impurities present, 1. Then second, chemicals used in various stages of preparation. Then third, the water supply. And the fourth one is the type of machineries used for the pretreatment. After that, the important stage comes, that is the pretreatment. It is also called as cotton preparation. As a general rule, preparation processes are performed for cleaning the textile substrate prior to dyeing, printing or finishing. The essential objective of this process is to produce a substrate that has some important properties. Those properties are basically 3. one, even and rapid absorption of water. Then total removal of cotton seeds husk. And the third one is the ability to absorb dyes and chemicals uniformly. These pretreatments basically are singeing, desizing, scouring, then bleaching, and the last mercerizing and liquid ammonia treatment. Actually, mercerizing and liquid ammonia treatment many of the time commercially performed in a grey form or after desizing or after scouring. So last stage generally kept is of a bleaching. But theoretically mercerizing is a finishing process, but practically it is performed in the pre-treatment only. This preparation of own fabric normally consists of these three stages. In the first stage, desizing, scouring and bleaching. So these three common terminologies are used. In most of the other cases, preparation is in a two-stage, that is scouring and bleaching. And for certain end uses, the extra stage, that is of a mercerization, is used. So it can include for yarns and fabrics also. Woven fabrics also requires sometime singeing prior to desizing. Also, many end products are required to have very high whiteness in order to be printed, dyed to be a light pastel shades or to be sold as a market white. Preparation processes must be carefully controlled to minimize fiber damage, which can lead to the fabric yellowing or even strength losses. Singeing is one of the few preparation processes which is not a wet process. It is mechanical process. Many woven fabrics are singed to remove the surface fibers. The fabric from an accumulator is passed through a brushing unit and then into a singeing machine. Most usual having a gas-fired burners through which the fabric passes at high speed in such a way that both the sides of the fabrics are get singed. The fabric is passed through a steam or liquor to quench any sparks. When a liquor is used, it is often a desizing liquor. The purpose of this process is generally to process a smooth yarn or fabric surface to increase the luster of the fabric or yarn or the smooth feel of the final end product. This process is also reducing the pilling tendency of the end product. As shown in figure number 1, yarn hairiness reduces after singeing. Yarns are usually singed individually on a single end singer and then it is repackaged onto cones followed by further processing. These yarns typically are used for high quality products. The fabric singeing is more traditional than yarn singeing. As it is shown in the figure 2, the fabric is dry and it is in open width form and passed through the gas flames of the singeing machine, or we can say singer burners. These burners are essentially horizontal pipes with holes across the width of the pipe. Natural or propane gas is passed through the burners and ignited. Desizing is a preparation process which is used only for woven fabrics. It is the wet process that degrades and removes the sizing materials which are applied to the warp yarns of the woven fabric. These sizing materials must be removed to enable the fabric to uniformly absorb the dyes or finishing chemicals. Additionally, these materials, if not removed, can also interfere with various mechanical finishing processes, resulting in poor end product quality and or finishing defects. This process is never used on knitted fabrics because sizing materials are not applied to yarns used for knitting. The content of the warp size formulations, including the chemical nature of the sizing materials, are key factors in determining the type of desizing processes used to completely remove these materials from the fabric. A typical sizing formulation can include a film former such as vegetable starch lubricants, binders, antistats and waxes. The main important factor is the thickness used in the sizing material. Four types of thickeners are used, in which first is the natural starches from potatoes, maize starch, size or topeka. The second type of thickeners are chemically modified starches. Third one is the organic polymers, for example polyacrylates, carboxymethyl cellulose, methyl cellulose, polyvinyl alcohol. And solvent soluble materials, for example copolymers of methyl methacrylate. Whenever the thickeners are used, out of these four any one, individual thickness requires the separate process of a removal treatment. For example, few are easily water soluble and few requires the typical process of degradation. Vegetable starches like cornstarch or rice starch are mixed with water and cooked. They form a strong, smooth, water-insoluble film. In order to desize these materials, they must be degraded to water-soluble components by using alpha amylase enzymes. This is followed by rinsing the fabric multiple times with water to remove residues. Synthetic sizing materials such as PVA, polyvinyl alcohol, or CMC, carboxymethyl cellulose, or PAA, polyacrylic acids, are normally water soluble. These materials can usually be easily removed by using a warm water or even hot wash, which includes detergents and alkali. The specifics of the time and temperature of processing is mainly depends on the exact nature of the synthetic material and the amount of it that is present. Specifically, PVA is often captured from the desizing process and it can be recycled. The vegetable starches cannot be recycled, while the other synthetic sizing materials are not cost effective when recycled. This size removal is also depends on those factors we will discuss. In that, the first important factor is viscosity of size in the solution. Means at the time of sizing, if viscosity, if it is a very low, then penetration of size material in the yarn will be more, removal will be difficult. If viscosity is too high, then penetration will be less, coating on the yarn will be limited, removal will be easy. But according to the required strength for the warp, the sizing viscosity matters more to strengthen the warp threads. So here viscosity is directly related to the penetration of the size material into the yarn. If penetration is higher, definitely the removal process should be lengthy. The second factor is the ease of dissolution of the size film on the fiber. When dissolution of which type of thickener is used, out of above 4 varieties, as the dissolution of certain thickeners, if it is easy, then removal will be easy. Then third important factor is how much amount of that thickeners or size materials are used for the sizing. Then nature and amount of the plasticizers used. These plasticizers are nothing but the polymers. They are forming the film over the fiber. And if plasticizer amount, if it is higher, penetration of desizing chemical for the desizing of these starches is again very lengthy, and they cannot reach up to the thickening agents, and definitely removal will become more difficult. So optimum concentration of plasticizer requirement is the basic need. Then fabric construction. If the open type of fabric, if it is, then less amount of ends per inch, less amount of picks per inch, then penetration of desizing chemical will be better. Again, the thickness of the fabric or construction of the fabric, if it is a too tight, then penetration of that desizing chemical is more difficult. Definitely desizing time should be given more. Then method and nature of washing up process. After the desizing, removal of degraded size, by which process or on which machine we are removing, that is also important. Otherwise, amount of size removal from the fabric will be more lengthy, or we can say it is more difficult also. So appropriate washing up process has to be there. And the last point, that is the temperature of washing up. Sometimes some sizes require typical temperature for the removal from the fabric, and some sizes are getting removed easily even at a room temperature washing. So accordingly we have to select the temperature of washing up process. After types of size materials and factors responsible for removal of these sizes, the next important steps come, that is methods of desizing. Under methods of desizing, enzyme desizing is widely practiced and is highly effective for degrading starch or starch-based sizes. The enzymes used are the alpha amylase, and they are frequently applied in the quench box of the singeing machine on the immediately after the singeing, but may be used on almost all types of batch and continuous equipments. The desizing chemicals bath is used to quench the spark and embers from singeing. The saturated fabric of desizing chemical then travels into the fabric steamer, where it is allowed to dwell for 10 to 20 minutes to get the degradation of the size material which is present over the fabric. These components subsequently are removed by rinsing the fabric in a series of fabric washers. An important quality control factor is to test for residual sizing materials. So many of the time take-over test is checked or residual size material present is analyzed gravimetrically in a quality control lab. The various preservatives used like halogenated phenols added to the size mixtures to prevent mildew formation on a damp fabric are toxic to the enzymes, and they create the difficulty to make the enzymes activate. These anionic surfactants are also added, are also creating the problem at the time of enzyme desizing. Another method of desizing is the oxidative desizing, where sodium hypochlorite or hydrogen peroxide is used. So as a cellulose is a part of starch material and also it is a part of a fiber. So here, because of very low degree of polymerization of these size materials, they become very immediately degrade due to these oxidizing agents, and decomposition of these starch takes place. Very minor effect on the fabric means where the cellulose is present in the actual cotton fiber. So that is also one of the process, but chances are there to get some higher amount of a degradation of the fabric because oxidizing agents damages the starch. At the same time there is a minor damage to the cotton fiber also. The third type of desizing method is the hot caustic soda treatment, where hydrolysis of size material takes place. Because of that disintegration of size material, which in the next process of washing, the disintegrated size material will be completely removed from the fabric. Many of the time this process is very rarely used, so causticization is the one of the process, not actually mercerization, but the lower concentration of caustics are taken for the treatment. So simultaneous some effect of mercerization and desizing in one bath is a process. So for the medium to lighter varieties, this process is also carried out. Then hot washing with a detergent. Many sizes, sometimes the water soluble. These are the modified starches. So they can be removed either with a very warm water or cold water as we discussed previously. So only with a detergent to get the better penetration into the fabric, hot washing is carried out. So there will be a better removal of size materials. The last one process is the solvent soluble sizes. So copolymers or polymeric sizing materials, whenever it is applied, so sometimes solvents are used, so they can be completely removing these polymeric compounds which are present over the fabric, and the material, the desized material can be recycled. So from the ecological point of view, it is the best process. Solvents can be also recycled, and desized material is also recycled for the next process of sizing and next process of desizing. But this process is slightly costlier as compared to the above 4-1. So for the very high quality varieties, this process is carried out. Scouring is the process used on both knitted and woven fabrics, where the impurities in the fabric are removed by washing. Usually the only major impurity not removed by process, that is color. Otherwise majority of all the impurities are removed in the scouring process. The results from well executed scouring process is include a uniformly clean base for dyeing yarns and fabrics in all shade ranges. Then removal of fats, waxes, oil, greases and dirt. Then better textile substrate absorbency resulting in more uniform subsequent processing. Then softening and preconditioning cotton modes for removal in bleaching, and a clean and natural base for finishing. Natural impurities will pass through the yarn and fabric manufacturing processes. In addition, the textile substrate will also include many of the added impurities which are listed below. Fiber finishes. Generally in the man-made and synthetic fibers, these fiber finishes are used as a lubricant. Then tints. For finding out the various counts, some tints are added at the time of spinning. Then sizing materials. Before weaving, as a preparatory process, sizes are applied over the warp. Then some markings after preparation of the fabric is done with the waxy pencils. Then lubricants. So these lubricants on the fiber and at the time of manufacturing processes are stuck up on the fiber surface. Then oils. So these oils are as anti-static oils are generally used for the synthetic fibers. Then greases, which are used for the machine various parts, are giving marks over the fabric or yarn surface. Due to the sticky surface of the fiber and yarn and fabrics, dirt and rust is getting stuck up over the surface. And metals in lubricants are another major added impurity. All of these impurities should be thoroughly removed prior to dyeing, or their presence can lead to poor dyeing quality, poor finishing performance, and end product defects. Unlike desizing, scouring is absolutely necessary for all other fabrics and all dyed shades. Scouring is the single most critical process in preparation. Insufficient scouring results in poor performance in many subsequent processes, especially dyeing and chemical finishing. Residual impurities left from poor scouring results in dye blotches, streaks and spots, as well as insufficient finishing performances. Residual oils left on the fabric can degrade during the storage, resulting in fabric yellowing. Additionally, degrading impurities can also result in the formation of noxious fabric odors. The effectiveness of a scouring process is normally evaluated by using a laboratory method which involves extraction of residual oils, greases and dirt. The amount of residual materials extracted is correlated to the degree of cleanliness of the substrate. However, companies often use a quick method where a few drops of clean water are placed on the dry scoured fabric surface. The time taken for the drop to be absorbed in recorded, and then normally clean scoured fabrics should absorb the water in 1 to 3 seconds. This test is also called as dropped absorbency test. After scouring, the next process of pretreatment is the bleaching. In bleaching, under oxidative bleaching process, because it is a very common to the cotton material, hypochlorite bleaching. In that, calcium hypochlorite and sodium hypochlorite are the two methods. Calcium hypochlorite is not commonly used because of the calcium deposition. So sodium hypochlorite is the very common process for bleaching of cotton material. This process having some advantages. In that, the first advantage is low chemical cost. This sodium hypochlorite is prepared in-house during pretreatment. So the cost of preparation of the sodium hypochlorite is the least. So at the end, the process cost due to the sodium hypochlorite is very low compared to all other bleaching methods. The risk of chemical damage to the cellulosic material is also very low because decomposition due to the metal contact is very least among all the bleaching agents. So ultimately, the degradation due to the metallic contact of cotton material is very low in case of sodium hypochlorite. The sodium hypochlorite process is always performed at room temperature, so no external heating is required, and therefore the energy cost of this bleaching process is very low. At the same time, some disadvantages are there of sodium hypochlorite, and that the major one, because sodium hypochlorite is a non-eco-friendly in nature. So AOX level is very high, so absorbed organic halogens. So these residual halogen compounds are responsible to make the non-eco-friendly nature of the textile material. Then there is no rapid bleaching process because sodium hypochlorite is a very slow process of bleaching. So we cannot alter the pH, otherwise there is a degradation. Some few experiments for the rapid sodium hypochlorite bleaching processes are made, but they are not that much successful because they are degrading the cotton. Then the traces of sodium hypochlorite, if it remains with the fiber, and it remaining always, are responsible for making the fabric yellowing. So these traces are very difficult to remove 100%. So these traces are whenever the fabric becomes after the bleaching comes in contact with the atmospheric condition, so it becomes slightly yellower in nature. Then danger of chemical damage to the cellulose. At the same time, whenever the sodium hypochlorite slightly, suppose the bath temperature increases, then there is a chance of formation of oxycellulose formation. Suppose the pH control is not very specific, 9.5 to 10.5, then also the damage of cellulosic material will be high. So this process is very much controlled at a specific pH and lowest temperature. So that is also the major disadvantage, because from the reproducibility point of view, these two things has to be maintained as a process control parameters. Then fabric, whenever is taken for the bleaching, if it is not very well scoured, then definitely hypochlorite treatment is not that much effective. So whitening of the fabric due to the sodium hypochlorite is mainly depend on how the pre-scoured fabric is there. If scouring process is not up to the mark, then definitely hypochlorite bleaching process will be very ineffective. Then degrades most of the dyes and fluorescent agents, means fluorescent brightening agents. This traces of chlorine remains with the fabric is mainly responsible to this damage of coloring matter. So chromophores from the dyes are getting affected due to these chlorine traces, and also at the same time, whenever in case of full white fabric, optical brightening agents are added, so those optical brightening agents are not compatible with the sodium hypochlorite. Another oxidative bleaching agent is hydrogen peroxide. Hydrogen peroxide is also called a universal bleaching agent because, and it is a safe bleaching agent. It can apply his oxidation process at a very wide range of pH level. So damage to the fabric is very less. Even at lower temperature to very high temperature up to 120, 130. So it bleaches the cotton. Only the time will vary, and therefore it is very commonly used in the bleaching. This bleaching agent is having some advantage, that is no need to severe pre-cleaning process because bleaching is carried out at alkaline condition, and generally 90 to 100 degrees centigrade is the temperature taken for the bleaching. So many of the time combined scouring and bleaching, both the process can be carried out, and therefore this bleaching is not require very severe scouring process. No need to exotic materials of construction, but iron and copper must not be used. In this bleaching process, whenever the fabric is taken, only precaution required is to avoid the catalytic degradation. Iron and copper should not contain either with the fabric as ash content or either with the water which is taken for the processing. Otherwise, no any other precautions majorly required to take at the time of a bleaching. It is environmentally accepted process, so no AOX as it was in a sodium hypochlorite process. So after decomposition of hydrogen peroxide, there definitely water and oxygen will evolve. So no any residual harmful products are remaining over the fabric. Decomposition products are the oxygen and water. So actually it is not harmful from the ecological point of view. Therefore it is a safe bleaching agent. This bleaching agent is also having a very good storage stability. Only the acidic pH conditions are required at the time of storage. So decomposition in a dark black colored carbon, so they can remain for the longer time. It is not in case of sodium hypochlorite because decomposition of sodium hypochlorite even at alkaline pH is continuously going on. So whenever the reproducibility is the concern, so at that time the stability or storage stability is very much highly concerned. Compatible with most of the fluorescent brightening agents. So many of the time even after the bleaching or along with the bleaching, fluorescent brightening agents are added. So in this case, so bleaching with the hydrogen peroxide gives the good support for the fluorescent brightening agent. Generally fluorescent brightening agents are added for the fabric which is kept as a complete white. Then it gives versatile processing. Means this hydrogen peroxide bleaching is suitable for batch process, continuous process, even at cold process. Means bleaching with hydrogen peroxide also carried out at room temperature in a pad batch process, means semi-continuous form. Then very hot conditions, that is a rapid bleaching. So whenever the temperature is taken 110, 120 degrees centigrade. So here majority of the fibers are very good compatible with this bleaching method because many of the different types of process methods are practically possible with the hydrogen peroxide. Then product produces a stable white fiber with a good absorbency because whenever the scoured fabric is taken for the hydrogen peroxide bleaching, so hydrogen peroxide bleaching along with the scouring agent or along with the alkali, whenever it is boils the fabric, so whatever the residual impurities are there, hydrophobic impurities are completely removed off and we are getting the very good absorbent fabric. Allows root shortening by combining stages. Many of the time one bath desizing, scouring and bleaching, one bath scouring and bleaching. So these processes are possible only with the hydrogen peroxide bleaching, because in case of hydrogen peroxide bleaching, temperature whenever is taken, so that temperature cannot be utilized only for the bleaching but along with the scouring also. Only by extending the amount of alkali in the bath we can go for the combination processes. So as we have seen in a desizing, oxidative desizing method, so hydrogen peroxide is oxidizing agent, so it oxidizes the size material. The alkali present in the recipe of hydrogen peroxide scours the fabric, and hydrogen peroxide at the same time decolorize the pigments from the fiber. So all the processes can be combinedly performed over cotton with the help of hydrogen peroxide. Some disadvantages are also there with this hydrogen peroxide, but are very few. Some water is always transported, means hydrogen peroxide whenever it is transported or stored, after the decomposition the remaining content is the water. So whenever we are storing the fabric or we are storing the hydrogen peroxide or we are transporting the hydrogen peroxide, so some amount of water content is definitely there. Then sensitivity to the metallic impurities. Hydrogen peroxide is very much sensitive to the metallic impurities, so many of the time the sequestering agents are added in the bath at the time of bleaching to avoid the metallic decomposition of cotton. But hydrogen peroxide, even at the time of a storage, if that water, whenever it is gets diluted, so if water contains some kind of a metallic ions, decomposition of peroxide starts. Again, multi-chemical baths which needs control. Whenever many of the time few auxiliaries are added, so at that time control is essential, otherwise there will be a rapid decomposition of hydrogen peroxide. And last is the comparatively it is expensive, because hydrogen peroxide, the base cost of product comparatively it is higher. Energy is required for the efficient absorbent white fabric. So definitely bleaching cost among all the bleaching methods is higher in case of hydrogen peroxide. Next oxidizing bleaching method is sodium chloride bleaching. Sodium chloride bleaching is mainly not used for 100% cotton fabric, because sodium chloride process is mainly carried out to acidic pH, at acidic pH, and it damages the cotton fiber strength. So whenever cotton is blended with the synthetic fibers, synthetic fiber content in the fabric, if it is more than 50, 60, 70%, then only this method is used. Otherwise, for 100% cotton, this process is not common. This process is having few advantages. No need for severe pre-cleaning treatments. As we discussed earlier, this process is suitable for synthetic fibers. Synthetic fiber contains only the added impurities. So added impurities can be removed very easily in the pre-cleaning process, because all the added impurities are easily removable either with emulsification or detergency. So minor washings are also removed off. So no any specific severe pre-cleaning treatment is required. Then smaller weight losses due to non-scouring actions of acid bleach, because acidic conditions, whatever the amount of cotton content is there, so it gets hydrolyzed. Because of that, the weight loss of the fiber is definitely high, specifically in case of cellulosic fibers. For synthetic 100% cotton fabric, if this bleaching process performed, then there is no any such major weight losses. Soft fabric handle and good sewability due to non-removal of fats. Bleaching method is performed at 60-70 degrees centigrade maximum. So removal of fat is not a major concern, because acid is only taken. So here, due to the acid, some fine degradation of fiber gives the good handle to the fiber surface. At the same time, some fatty matters remain with the fabric. So sewability of a fabric is very much easy, and therefore such fabrics require this process. So definitely sewability is the sometime major requirement. So at that time this bleaching process is performed. Low chemical damage because of very shortening process. Chemical damage to the fiber can be controlled. In case of a synthetic fiber, chemical damage is very much negligible. In case of cellulosic fibers, they are getting definitely damage of. But actually this process is suitable for synthetic fibers, so chemical damage is very low. Least sensitive to the metallic contamination due to the hardness of ions or due to the ions present, metallic ions present in the water, or any machine metallic body contact are not decomposing the fiber, because decomposition of sodium chloride is not because of the metallic decomposition. Then bleaches synthetic fibers, or earlier as we discussed. So this bleaching method is majorly suitable for the synthetic fibers because all synthetic fibers are withstanding to the acidic condition. Acid process makes the washing off easier. Removal of acid is very much easy as compared with the removal of alkali. In all previous two processes, alkali was the medium to maintain the pH. So after the bleaching, amount of water required to remove the alkali from the fabric is more. But for sodium chloride, acidic pH is required, so acids are used. So acids can be easily washed out after the bleaching process. So amount of water required for the bleaching definitely will be very less. Few disadvantages are there of this process, in that a possibility of liberating toxic gases, that is chlorine dioxide. This process, during the reaction, chlorine dioxide is a harmful gas mainly responsible for suffocation. So this process is generally carried out in a very closed vessels. Very specific equipments are required. Even at the time of operation, some leakages from the machines, if it is there, so those are very toxic. So major precautions are required. Then equipment is expensive because of the need of exotic construction materials. The sodium chloride is highly corrosive in nature. So whenever the fibers are taken for the bleaching, so the solution of bleaching bath is highly corrosive. So very specific interline machines are required, and because of that the cost of the basic machine is very much higher. Then no rapid bleach process available. The bleach process is very much slow and constant one, so rapid decomposition of bleaching is not possible because of varying in any pH. Poor absorbency due to residual fats and waxes. As we discussed, temperature is not taken higher. Amount of waxes remains with the fabric is more, so absorbency definitely gets affected. So as compared to the bleaching with hydrogen peroxide, absorbency in case of sodium chloride is definitely low. It is expensive because it is a two-stage process of bleaching. Basic cost of chemical is high. Equipment cost is also high due to this very specific equipments required. So overall cost of bleaching is higher in case of sodium chloride. Incompatible with most of the dyes and FBS. As we have seen for the sodium hypochlorite, this bleaching method agent is also very much incompatible because majority of the brightening agents are affected and they are decolorized or they are non-active to make the fabric brighter. So the FBS are not commonly used in the sodium chloride bath. And multi-chemical baths which needs control. Whenever the sodium chloride bleaching is taken, so acids are there, some non-corrosive agent, sodium nitrates is also added. So these many number of chemicals require some control by temperature, by pH. So any variation in the condition changes, definitely there will be some sort of a damage to the fiber or requires a very specific precautions at the time of bleaching. After bleaching, the process is mercerization. Mercerization is an optional quality improvement preparation process. It is used almost exclusively for cotton. It is one of the oldest modern finishing process. Today, it is mainly used for cotton fabrics, but can also be used for cotton yarns. This process involves the treatment of cotton yarns or fabric held under tension while being treated with a strong sodium hydroxide solutions. In the figure 1, it shows a schematic diagram of mercerization process. In the initial section of the range, the fabric is impregnated with the sodium hydroxide solution. In this example, 22 to 30% solution of caustic soda, sodium hydroxide, is applied to the cotton fiber held under tension at room temperature. The caustic soda causes the fiber to swell and the internal cellulose molecules rearrange to form the cellulose 2 structure from the standard cellulose 1 configuration. The subsequent swelling of the fiber molecules collapses the lumen. The fabric is passed over timing rollers to allow the caustic enough dwell time at ambient temperature to accomplish the process. This step is also called skying. The total dwell time of this caustic soda in the fiber prior to washing is normally 30 to 60 seconds. In the stabilization section, the fabric is held by the edges in order to exert the tension necessary for the full development of the final mercerized fabric properties. Cascade rinsing is a counterflow washing process where the cleanest water is introduced through the last cascade unit. The water in this process is heated up to 98 to 99 degrees centigrade, we can say up to boil, to remove the caustic soda. The first cascade washer uses the water which is most saturated with the caustic. This dirty water is captured after passing through the fabric. The caustic soda is thus separated from this wastewater and recycled. The mercerized fabric is thoroughly washed and any residual alkali is neutralized. The fabric may be stored wet or dry prior to dyeing and further processing. Once the caustic soda is removed by thorough washing, the cotton substrate is dried and returns to approximately its original size, but in a different cross-sectional shape. The figure 2 shows an artist's concept of the changes in cross-sectional shape of a cotton fiber during the mercerization process. You notice carefully the non-uniform uneven appearance and various shapes of unmercerized fibers. After the dwell time, slowly development of the shape of the fiber, and at the end the fiber becomes more circular in nature. Also, it can be seen that the lumen has collapsed due to various degrees. So at the end, very smaller lumen and very circular cross section gives a lustre to the mercerized fiber. The figure 3 is the actual microscopic photographs of unmercerized and mercerized fibers. Unmercerized fibers, if you see, very long lumen and collapsed walls. But in case of mercerized fiber cross section, very small lumen and some circular cross section of a cotton fiber. Definitely the thickness of wall is improved and lustre and shining of the fiber at the end is at a higher level as compared to the unmercerized fiber. The positive results of the mercerization process includes increased dyeability and uniformity. Dye yield by the mercerized fibers can be as much as 20 to 25% increase in the shade depth over unmercerized. This can be a major cost saving because a given shade may be obtained using approximately 20% less dye. Mercerized cotton substrate show up to a 20% increase in the tensile strength. These products are normally dimensionally stable and absorb water and chemicals more rapidly than non-mercerized substrates. Mercerization significantly improves the lustre of the product because of the substrate is kept high tensions. The fiber surface becomes significantly smoother and reflects light in a mirror-like fashion. Many bales of cotton have some immature fibers. These fibers have a primary wall, but due to some growing conditions, they did not grow a significant amount of cellulose in the secondary wall. Some immature fibers have no secondary wall cellulose and will not dye and appear as white specks in a dyed fabric. A name often applied to these fibers is a dead cotton. In the figure 1, the white circular in white circles, the dots are there, so those are the dead cottons. The mercerization is the only process commonly used to remedy problems resulting from immature fibers. The same fabric, when it is mercerized, so that fabric will not have any dead cotton, so the fabric depth is also higher, and at the same time the dead cotton white spots will be disappear. This process will swell any small amount of cellulose present in the immature fibers so that they will be dyeable as shown in the figure 2. Any non-cellulosic material in the fabric will also be destroyed and washed away during processing. After fabric mercerization, yarns are also mercerized. So yarn mercerization uses essentially the same type of mercerizing bath and similar processing conditions. However, yarn mercerization is a more complex process. The yarn is taken off creels to form yarn ropes which go through the mercerizing process. These ropes must then be dried and the mercerized yarns must be individually rewound onto packages prior to fabric manufacturing, typically in case of knitting. Yarn mercerization is the only possible with piled yarns due to the high tensions used to create lustre. The best results are obtained when the yarns are singed prior to mercerization. These yarns can be dyed prior to knitting or dyed after knitting in fabric or garment form. These yarns are often mercerized in fabric form after knitting. These products, a cotton product with extremely high luster, this product is known as double mercerized because in case of yarn it is mercerized, once the fabric is prepared again it is mercerized. The figure shows a schematic of the yarn mercerizing process. So where on the creel for yarn package, so caustic soda from 22 to 30%, generally 25 to 30% is the range of a caustic soda concentration taken. So hanks are prepared. Then the hanks are taken onto the sodium hydroxide saturator for about 15 to 20 seconds. Then they are heavily squeezed with a squeezing roller for 30 to 60 seconds. At the same time they are extended because the elasticity develops into the cotton. At the same extended or stretched form of a hank, the yarns are washed and neutralized. So at the time of washing, very hot water up to boil, then followed by cold rinses, and then it is neutralized with acetic acid is used. So where the pH of the extract of the hank should be near neutral. After that the hanks are dried and again it is rewound on the packages, and those packages are taken for the knitting afterwards. So this is a general process sequence for the yarn mercerization. So in the conclusion, we have seen what are the different impurities present over the cotton, natural and added impurities, then how these impurities are removed, the sequence of pre-treatment, how the individual stage of pre-treatment is helping to improve the quality of dyed material, and ultimately all these pre-treatments how gives the effect and how make the simple coloration process, so that we have seen. So generally it is called the well prepared is the half dyed. So here all these pre-treatments, if we carried out very effectively, then the good quality of dyed material will be easy.